Hi, my name is Chris Ashworth, and I'm here today to explain to you a little bit more detail of what we're talking about when we're increasing the speeds of our water jet cuts, and how are we accomplishing it where nobody's had any significant improvements in the last 20 years. The reality is we're taking a little bit of, actually the technology was started 20 years ago as it is, never really made it into the mainstream. So the details of what we're doing is we're actually using shaped nozzle cutting. We're actually taking the end of the nozzle and EDM shape into it, and like whether it's a 20 by 60 or a 30 by 60, 40 by, any shape is possible. A square nozzle works as well. Some of that, we'll get into some more details on what square nozzles can do for you further down the road. In the background, you can see it's not just a matter of the shaped nozzle, but you also have to have the motion that supports it. And what you see going on in the background here is we got the 5-axis head is actually using lead and lag into the process of cutting, so that we're actually trying to get a common chordal height from the top to the bottom, so the stream entering the metal is coming out the bottom at the exact same location, which allows us to have less metal to cut when it comes time to corner, piercing and things along those lines. Here we're actually leading on this part in at 9 degrees, and then in the corners, the whole idea is that you have to manage the bottom of the cut, what's going on in the tail. And the tail is, in this scenario, the way we're doing the corners, the tail stays deflects into the scrap and not into your part. So when it's all said and done, you end up with a perfectly square part on top as well as on the bottom. Taperless cutting can be done as well, but with the blade you get a little more punch through the surface, and it's not nearly as significant as it would be with conventional water jet cutting. Now, to get into some of the more details as to what we're doing with this angle, and you pierce and you start to lead into it, but when you come to the corner, you'll notice that the head begins to stand up. We'll get into a little more on the whiteboard here in a minute to give you some details of what's going on in the cut itself. But in this particular case, we have some parts here that we cut with a 20 by 60, so you got a very tight curve, but yet you're able to carry speeds of like 3.5 inches a minute and still have like a Q2, Q2.5 finish, somewhere in that range. Which, at that speed, you're also going to use less abrasive, which also becomes more attractive. Looking at the way this thing stands up like it is, we can now go to the whiteboard and I can kind of explain what's going on in the cut itself. In a previous video, I went over a little bit about the motion of what we're doing with the water jet head. Now I'm going to get into more details of what's going on in the cut of the water jet head. Conventional water jet cutting, if you're just doing a 3-axis cut, you can see that we have a trail, and everybody knows that's in the industry understands this, is you're going to have the deflection of the stream as you're cutting through, especially thicker materials. Thin materials, a lot of this technology doesn't apply, but that's not really what it's all about. But as you get thicker in material, you get more and more deflection. This distance here can become pretty extreme as you start cutting 3, 5, 8-inch thick materials. The idea here is that we're going to tilt the head to the point that we don't have this much material that we have to worry about when we're going around a corner. The idea is we actually work with the chordal height here, tilt this thing so that where the water's entering the material here, it's exiting at the same place. So now when I come to the corner, all I have to do is stand this up and knock these 2 little tabs off versus cutting all this material and waiting a significant amount of time for this to get to the corners. So the idea of just cutting faster it doesn't completely apply to what we're talking about. It's also got to do with the process and what takes place during that cut. Now, as far as what we're doing with the shape, down below here, this is when you look at the end of the nozzle, this is what you're going to see. And in this case that I was doing in the video earlier, it was a 20 by 60, and we have some close-ups of what the cut looks like that they'll be getting into as this video is put together. But what you see here is we have a rectangular shape that would be in the center of your nozzle, but we also, how do you control where that is, and how difficult is it to put it in the same place every time? The idea is that the nozzle actually has a key in it, or a flat, then that flat is in alignment with whatever shape you put into the nozzle. So it allows us to put it right back into the head at the exact same location as it does as you would with just a standard nozzle. And the next step is we're actually going to make this more of a, where the key here doesn't matter as much as what's going on up inside the mixing chamber. And that'll be a video in the future, so stick around for some more details.